Hello Prep 3 students, how are you? Now it's time to solve together the models of geometry. The first model from the Manchester School book, starting with choose questions. The first question is, the inscribed angle drawn in a semicircle is what? The inscribed angle drawn in a semicircle is what? It's known that the inscribed angle in semicircle is right angle. So we will choose is right. Okay, mister, we know that the inscribed angle drawn in semicircle is right, but why? Okay, let's draw a circle here. Here is my circle. Okay. Now let's draw an inscribed angle in the semicircle. Like that. What is the measure of this angle? The measure of the inscribed angle, as you know, is half the measure of the opposite arc to this angle. The opposite arc to this angle is half of the circle. So its measure is 180. The measure of the arc is 180. The measure of the inscribed angle equal half of the measure of the arc. So half of 180, which is 90 degrees. 90 degrees means it's a right angle. It's a very, very important question. You will use it inside proof questions. If you have an inscribed angle drawn in semicircle, the measure of this inscribed angle equal 90 degrees. Question number 2. In the opposite figure, circle of center M, if measure of the arc AB, the measure of this arc AB is 50 degrees. Find measure of angle ADB. He asked me about the measure of this angle. The first step to determine the measure of any angle inside the circle, in my opinion, you have firstly to determine or to recognize the type of this angle. This angle is inscribed central, then angle tangency, or otherwise. Here, the angle that he asking me about is inscribed angle. The measure of the inscribed angle equal half of the measure of the angle, the central angle subtended by the same arc, or half of the measure of the arc. Here he said that the measure of my arc 50 degrees, so the measure of the inscribed half of the arc, half of 50, which is 25 degrees. Question number 3. The number of symmetric axes of any circle is what? Any circle has infinite number of axes of symmetry. There is infinite axes that can divide my circle into two identical parts. So the number of the axes of symmetry of any circle is an infinite number. Question number 4. In the opposite figure, measure of angle A is 120. Here is A, 120. The question is, what is the measure of angle B? Or angle C, sorry. Okay, as you see here, my figure ABCD is a cyclic quad. Cyclic quad because the four vertices are lying on the circle. So my figure here is cyclic quad. What is the question? The question is, what is the measure of angle C? In the cyclic quad, we know that each two opposite angles are supplementary. This is one of the properties of the cyclic quad. So, supplementary means what? Means their sum equal 180. So, A and C together, 180. One of them, 120. So, the other will be 60 degrees. 180 minus 120. Question number 5. If the straight line is tangent to circle M of diameter A, then the distance between L and the center of circle is what? Very easy question. We have circle of center M, okay? We have the straight line L, which is tangent. Tangent, like that, okay? He said the diameter is 8, okay? And the question is, what is the distance between the line L and the center? Here is the center. Here is the line L. The question is, what is this distance? this distance is a radius, and we know the radius is half of the diameter. The diameter here is 8, so the radius is 4, the distance will be 4. We know that the distance between the tangent of the circle and the center of the circle is equal to the radius. Question number 6. If the surface area of circle M intersects the surface area of circle N equal A. Two circles intersects at only one point. This means what? The meaning of this that the two circles are touching externally. When we have two circles with only one point of intersection between their surfaces, that means the two circles are touching externally. We have two touching externally circles. Let's draw the circles and say what is the required. Okay, like that. We have two circles with only one point of intersection, so the two circles are touching externally. Okay, the question is, here the circle M, and here the circle M. The radius of one of them is 3 centimeters. Okay, here this radius is 3 centimeters. Mn is 8. Mn is the distance between the two centers is 8. This distance 8. This radius 3. The question is, what is the radius of the second circle? Of course, will be 8 minus 3, which is 5 centimeters. We know that Mn will be the sum of the two radii if the two circles are touching externally, like our case here. Here, question 2a, we have complete encyclic quad each two opposite angles are. We said it before while solving the choice questions. Encyclic quad each two opposite angles are supplementary. Supplementary means their sum equals 180. How to prove that? Because the two angles are inscribed angles. Each angle is opposite to arc and the other is opposite to the complement of the arc with respect to the circle. So the sum, the double of their sum will be 360, so their sum will be 100. Here is a very important, very important question. The question which will be in most of our exams is to prove that AXYC is cyclic quad when we have a quad drawn inside circle and we have tangent such that this tangent is parallel to one of my quad sides. We have tangent, so we have angle of tangency, by the way, and we have parallelism. Parallelism means we have alternate or correspond angles. Okay, to prove that my quad is cyclic quad, we want to prove what? We want to prove that my quad has any one of the properties of cyclic quad. What are the properties of cyclic quad? We have a lot. One of them, each two opposite angles are supplementary, as we said before, or the measure of exterior angle equal to the measure of the interior angle opposite to adjacent, or the two diagonals bisect each other. We have a lot, or we have two angles drawn from the same base and on one side are equal in measure. Okay, here for our quad we haven't diagonals, so I'll search for the opposite angles are supplementary or the measure of exterior angle equal the measure of interior angle opposite to adjacent. Here I have parallelism. This line is parallel to this line. It's a given. Okay, parallelism, so I'll search for alternate or corresponding angles. We have here the letter Z. which means alternate angle. So the measure of this angle equal to the measure of this angle. Let's write that. Measure of angle DBX equal measure of angle BXY. Why? Because we have parallelism. So these angles, these two angles are alternate angles. Right? There is alternate angles. Okay. And look here. What is the type of this angle with respect to circle? This angle formed by chord and tangent. Chord and tangent again. Chord and tangent means angle of tangency. The angle which is drawn by chord and the tangent, it's an angle of tangency. And we know that the measure of the angle of tangency equal to the measure of the inscribed angle subtended by the same arc. What is the arc here? The arc is have the same name of the chord. The chord here is AB, so the arc is AB. Okay. We have an inscribed angle on this arc. Absolutely, we have the same. So the measure of angle C equal the measure of angle ABD. Why? Inscribed angle and angle of tangency with same arc. Right. Measure angle C equals measure angle ABX. We have measure of angle C equal measure of angle DBX. Sorry, not ABX, it's ABD. And the same angle here equal to this angle. By this way, we know that measure of angle BXY, angle BXY, this angle will be equal to this angle. Therefore, measure of angle C equal measure of angle YXB. What is that? It's interior angle and exterior angle. Exterior equal interior opposite to adjacent. This is one of the cases of cyclic quad. So my figure here is cyclic quad. Here my question is first find the measure of angle DBC. BDC, the measure of this angle. I told you before to determine the measure of any angle inside a circle. The first step is to determine the type of this angle. Inside the circle, my angle here is inscribed or central or angle of tangency. It's inscribed angle. How did you know? Because it's formed by two chords. So it's an inscribed angle. Okay. We know that the measure of inscribed angle is equal to the measure of other inscribed angle if they have a common arc. What is the arc of this angle? The arc here is BC. We have another angle on the same arc, yes. The angle ACB, CAB is inscribed angle with common arc with the inscribed angle CDB. So this angle equal to this angle will be 30 degrees. This is the first requirement. And he asked about the length or the measure, of the arc AD. Look here. We have semicircle AB. The measure of the semicircle is 180. All over the arc is 180. is the measure of the arc BC? The arc BC, we have an inscribed angle on it. Its measure is 30 degrees, so the measure of the arc is 60. This arc is 60 degrees. O of our arc, the semicircle, is 180. We take 60 away, so the left to us is 120. We divide this 120 into two arcs, two equal arcs. So I make 120 divided by 2 will be 60. The measure of the arc AD will be 60 degrees. And the last required here is to prove that AB parallel DC. We want to prove that AB is parallel to DC. The key of parallelism, to prove the parallelism, our key is to get alternate or corresponding or interior angles. If my angles are alternate, there will be having the same measure. If corresponding the same measure. If interior will be supplementary. Here we have letter Z. So interior angle and measure angle CDB equal measure angle DBA, because the measure of this angle equal half of the arc, and we determined before that this arc is 60, so this angle will be 30. We have here two angles, two interior angles, and equal in measure. Since measure angle CDB equals measure angle DBA, and they are alternate angles, therefore CD parallel AB. If he said that we have parallelism, the meaning of that, the two alternate angles are equal in measure. Here we have alternate angles equal in measure, so the two lines are parallel. Here's one of the most important questions. He said calculate measure of angle DMH. DMH, the measure of this angle. Very, very, very important question. And very easy. This angle is inside a quad. The sum of measures of interior angles of any quad is 360. So to determine the measure of that angle, I make 360 minus the other three angles. One of them is given with 70. So we want to determine the measure of this angle and the measure of this angle. We have y midpoint of AC, and my is coming from the center, so it's perpendicular to it. The line which coming from the center bisecting chord will be perpendicular to the chord. We know that. So perpendicular means the angle here is 90 degrees. Using the same way here, we have line coming from the center, which is MX, and bisecting AB, so it's perpendicular to it. We have here another 90 degrees. 90, 90, 180, 70, so will be 250. We want to determine the measure of this part will be, the measure of this angle will be 360 minus 250, which is 110 degrees. 110 degrees. The second required is to prove that XD equal YH. XD equal YH. We have MH equal MD. Do you know why? MD equal MH? Because MD and MH are two radii, and in the semicircle, all of radii are equal in length. Okay, but we don't need to prove that, master. MD equal MH. Okay. And we have here equal chords. He said that the two chords are equal in length. Since AC equal equal AB, when we have two equal chords, this means what? This means that the two chords are equidistant from the center. Two equal chords means two equal distance. So mx equal my. Since AC equal AB, the chords, therefore mx equal my, the distance. Chords equal, so distance equal. Okay. This part equal to this part, and the bigger part equal to the bigger part. So the left here equal to the left here. Therefore, xd equal yh. Did you understand? Go to a new example. Here in this example, one of the most important questions is to determine or to prove that this quadrilateral is cycloquad. How to prove that this quad is a cyclic quad? Cycloquad means we can draw a circle passing through all its vertices. You wanna proving that this quad is cyclic. Okay, we have angles. From the givens, we have angles. The given told me about the direction that I should take it to reach the answer. The givens here have angles, so I'll go to the angles. Angles in cycloquad, so we may prove that each two opposite angles are supplementary, or the measure of exterior angle equal the measure of interior angle opposite to adjacent. In this quad, we have no exterior. There is no exterior angles here. So our way is to prove that each two opposite angles are supplementary. I think it's easy. Why? In triangle ABD, this triangle, we have AB equal AD, isosceles triangle. Measure angle ABC equal 30, therefore measure angle ADB equal 30. 30 and 30, 60. The measure of interior angle, the sum of measure of interior angle is 120. Take 60 away, is 108, sorry. Take 60 away, the last will be 120. Look here, measure of angle A, 120 degrees. Measure of angle C, 60. Opposite angles. And their sum is 180. Their sum 180 means the two angles are supplementary. So, measure of angle A plus measure of angle C equal 180 supplementary angles. So my figure ABCD is a cyclic. Here's also one of the most important questions. We have the triangle. Let's go to the given. He said that AD equal 5. Where is AD? AD here, 5 centimeters. BH equals 4. Where is BA? BH equals 4 centimeter. By the way, it won't be BH, it will be BE. Corrected in the school book. 4 centimeter. And DF is 3 centimeter. Of course, he means CF. 3 centimeters. Okay, the question is find the perimeter of the triangle ABC. The perimeter of triangle ABC. Perimeter of triangle means the sum of the length of the three sides. Where are my givens? My given is AD equal AF. We know that the two tangents drawn from the same point are equal in length. AD and AF are two tangents drawn from the same point. AD is 5, so AF will be 5. Same way, CF tangent, CE tangent, the two tangents are drawn from the same point, 3, so the other one will be 3. 4, the other one will be 4. Same idea. So, to get the perimeter, the length of this side is 9, 7, and 8. The perimeter will be 9 plus 7 plus 8. And as we started our revision with choice questions, let's end it with choice questions from model 2. The measure of the arc which equal half measure of circle is 180, because all of the circle is 360. Half of circle, half of 360, 180. The number of common tangents of two touching circles externally. Two circles that touch externally like this. How many common tangents between them? 1, 2, 3. 3 common tangents. The measure of the inscribed angle drawn in semicircle. We said it before, it's very important. It's right angle. Right angle means 90 degrees. The angle of tangency is included between what and what? Angle of tangency from its name between tangent. Tangent and what? Tangent and chord. Tangent and chord. Chord and tangent. A, B, C, D is cycle quad. Measure A, 60. He asking about measure C. A and C are two opposite angles. In cycle quad, each two opposite angles are supplementary. So their sum is 180. 180 minus 60, 120. M and M2 touching circles internally. Two touching internally with radii 9 and 5. Touching internally means like that. The questions about Mn, we know if my two circles are touching internally, Mn will be the difference between the two radii. The difference between 9 and 5. 9 minus 5, which is 4. That's all about our revision. We solved choice questions and many proofs. If you have any problem, just write your question in the comments and we will contact you. We wish you will get the homework inshallah. See you soon. Goodbye.